Hello, everyone, and welcome to today's class on Introduction to Machine Learning, also known as Artificial Intelligence. Now, this is artificial intelligence and machine learning is something that we have all heard about. Usually, a lot of people feel that this is a computer science related topic, and it doesn't really have much to do with business. But as I've researched and understood, it actually has a very strong correlation with business as we know it today. And I will explain why as we move forward with the lecture. But just to start off with, I want to go back into history and talk about something that interests all of us, which is the ability to make predictions or look into the future. Right from the beginning of time, there's been a great interest amongst people to be able to see the future. In other words, know what's going to happen tomorrow. Also, try to understand what decisions they should make so that their future is in accordance to what their desires are. Early on, there were certain mystics that would come and they would be able to look at crystal balls or be able to sort of, interpret dreams and be able to forecast futures. And those people were very renowned, and the kings and the queens in the earlier times would keep them close to them so that before they made any decisions, they would consult these mystics and ask them their opinion. And the reason was that they wanted to understand if they made a decision, what the outcome would be. In other words, predict. Nowadays, such predictions are being done through machine learning and artificial intelligence. Most businesses previously would rely on the aptitude and the intelligence of senior managers to make strong key decisions. Nowadays, a lot of that role of decision making is being done through machine learning and artificial intelligence. One caveat to doing machine learning is that you need a lot of data. And that's why, in the previous lecture, I have discussed big data analysis and the fact that nowadays there is a plethora of information and data points that companies are gathering. And it's being done in many different ways, through surveys, through various means. But that data is essential for machine learning to happen. And this data or big data is in many ways being compared to gold or something extremely valuable, because it's through that data of customers that machine learning can be done and very, very accurate predictions and business decisions can be made. Now, just imagine if, for example, you were in advertising, or you had a company and you were thinking of how to do your marketing. You realized that you wanted to make an ad. You didn't know which ad to take, which ad, maybe you consulted 3 ad agencies. They all came up with various ads, but you wanted to predict which ad would have the most impact so that you would be able to get, the most bang out of the buck. Meaning that, which ad would be the best for you and get you the most people interested to buy the product that you're marketing. Well, you can predict that. Not only that, you can, through machine learning, predict how much profits you would be earning through various means of advertising. Machine learning is also being done for advertising through social networks, such as Facebook and YouTube and all of these. So any ads being put on those platforms, predictions can be made on the impact that they will have. So now, if you knew in advance what marketing channels you should use, how much you should invest, what ad you should pick, just imagine how much easier and efficient the decision making would be. Because now you would know for sure. There's no guessing involved. And so, previously, there would be these heads of departments having long meetings. All of that has been reduced significantly thanks to machine learning and artificial intelligence. So hopefully, that's just one example I gave of advertising, but you can just imagine that, if you were in manufacturing, you wanted to determine what products to make, in what quantity, where to market them, how to market them, where to place them. Almost all of these decisions can be done through machine learning or artificial intelligence. And so that's why in today's day and age, everybody, all businesses across the world are getting more and more interested in machine learning, artificial intelligence, and big data, because you cannot do machine learning and artificial intelligence without big data. Okay, moving forward now. So if you look at the world of business, definitely nowadays, as I mentioned, the decision making is being done through machine learning and artificial, or also known as artificial intelligence. But before this phase came in, predictions were being made by businesses through regression. And so I'm sure a lot of you have heard about regression, and hopefully you've done a little bit of it in statistics, and also when you're doing your research reports, you've learned a little bit about it. But what regression basically does is it uses value of one or more variables to make a prediction about the value of an outcome. So in essence, there'll be two variables, and there will be data that will be plotted on a chart, right? And then what happens is, once the data is plotted on a chart on these two variables, so it could be, for example, height and weight, right? And so you're just plotting people's height and weight, right, all across this particular chart. And then you realize that, okay, well, these black dots are what you've plotted. So let's say these are the heights and weights of everybody in your class. And so there's some a little bit higher, some a little bit lower. And what happens is that eventually, once you've plotted everything, you see that, it is possible to sort of draw a line through all of these different black points and a straight line, right? And so that's kind of what a regression does. And then once you have this line, it's sort of easy to make a prediction. Okay, well, let's say somebody else comes in, probably they will be, somewhere along this line. Somebody new comes in the class. You will not expect their height and weight to be way up on the right-hand corner, upper right-hand corner. No, they're probably going to be within this range. And so this is a kind of a prediction. Okay, the next person who comes in this class, okay, this is probably, they're going to be somewhere along this line. And this can be used for this has been used in the past for many predictions in business, right? Okay, this has been, and so now the question is, okay, how good is this prediction? So in regression, there is something called R squared, right? And through this R squared, you can generally determine how good your prediction is. And if it's a good prediction, great, you can businesses can use it easily. Now, if not, then, you have certain problems, and you might realize that, look, I'm not being able to make a line through these points. They're scattered all over. There's no, if you feel that it's very difficult to make any sort of a line through the points, there's no correlation, there's no relationship, then many times it's better to use machine learning, because it's not possible to find that relationship. So I'm not going to go too much in detail of regression, because you can read up a little bit more about it. And I know that you already have a background on regression to a certain extent. But what the main point of regression is that you are looking at historical data that has already happened in the past, to make predictions about the value of an outcome of variables for new records. So you're looking at previous data, using that, analyzing that, looking for relationships within that data, and then you are making a prediction for the future. Okay, and again on this slide, it's mentioned R squared. Again, this is basically, it tells you how well the line that you've made is is fit, and so in how good of a prediction you can make. That's what an R squared tells you. So obviously, if the R squared is very good, your prediction is probably going to be very accurate. If it's really bad, it's going to be very difficult to make a prediction. Again, on this slide, it's mentioned that if data points are scattered all over the place, excuse me, then it's better to use machine learning instead of regression. And again, the reason is if there are points scattered all around, it's very difficult to sort of find that relationship and make any sort of a line through it. Okay, so now I'm going to slowly start shifting into the concepts regarding machine learning. I'm also going to explain, again, why is it important? Why is machine learning important for business students such as yourself? All right, one thing I do want to mention, if you do end up taking computer science and this really interests you, and there's so many courses that I think the government is offering right now, and whether it's Coursera or edX, I mean, there's just a ton of courses out there on machine learning. If this does interest you, you can pick up a course and learn more about algorithms and coding and all of this. So coding is basically done a lot on big data, but algorithms are basically models, okay? And you can learn a little bit more about the various models, and there's several softwares out there. And so these models are used to do machine learning or artificial intelligence by businesses. And so you can definitely learn a lot more about these. I'm in this class just giving you a flavor and overview of what machine learning and artificial intelligence is and how it's being used in businesses. So again, algorithms, they are a process or set of rules to be followed in calculations or other problem-solving operations, especially by a computer. So yeah, so models are basically, a set of rules that computers can follow. And these models are used, to make predictions, to help solve problems that companies are facing. And so put in the data. Again, through big data, as I mentioned, you have a lot of data. You put in the right data, you collect the right data, you have to organize it in a specific way. You apply an algorithm, and you can make a very accurate prediction. And again, those predictions are extremely valuable for businesses. Why? Because there are no ifs and maybes. You are able to predict the future through these algorithms. So in our day-to-day world, let me give you an example of machine learning where we can actually see machine learning happen. When you start let's say you make an email account, we all have email accounts in this class, and let's say you make a new email account. Immediately once you make that, your inbox is able to determine which emails that are coming in are valuable emails, and it's going to put them in your inbox. And then it's also going to be able to determine which emails are spam, meaning maybe they may be ads, they may be, emails that are not valuable. And so they will automatically be put in a spam account. You do not have to even inform the computer. You don't have to go and click each one of them and say, okay, put these in spam. That happens automatically. And so the question is, how is that done? Well, the computer or your inbox is automatically scanning the emails and being able to determine which to put in which category. And this is an example of machine learning that's happening in your day-to-day life. Let's look at some other examples of machine learning. Self-driving cars. Cars being able to, and again, cars are able to determine how fast they should go, when they should make a turn in self-driving cars, and many other decisions. That's all machine learning. Weather forecasting, based on on the information, certain forecasts are made. Stock trade analysis, hazards of new medicine. So I'm sure with this coronavirus that's come out recently, artificial intelligence is also being used to understand this virus and understand the coding of this virus, right? So even in medicine and in healthcare, artificial intelligence, fraud detection. If there is any sort of fraud that's happened, being able to detect who's done the fraud can be done through machine learning. Business forecasting, we've learned forecasting, or if you haven't, you will be learning how to do business forecasting. But doing forecasting to a very high level of accuracy can be done again through machine learning. Social networks, a lot of, for example, if there's a photograph, nowadays Facebook can do facial recognition and identify, tagging. It can actually figure it out without your even saying anything. Okay, this is your sister, this is your brother, this is your friend. You can just sort of analyze it but through facial recognition. And there's so many more features on social networks that are, you can see machine learning happening live. Customer likelihood. What is the likelihood of customers showing various behaviors? Again, all of these are, machine learning being used in real cases. Now, let me, when I started this class, I mentioned there's a lot of questions that can be answered through machine learning. I'm going to just describe a few more. Let's say you have, you want to understand, you have all these customers in your business, and you want to understand which customers are giving me the most profit. Which are the most profitable customers? Maybe once you know who those customers are, you can have a very specific marketing strategy customized for them. But first you want to understand, you have, let's say, tens of thousands of customers. Understanding who your most profitable customers are can be done through machine learning. Segmentation and classification. You may have, let's say, 100,000 different customers. You want to segment them, let's say by location. Again, this can be done through machine learning. Prediction. Let's say there's a new customer who walks in to a very large, jewelry store. You can determine through some data points of the customer whether this customer will become a profitable customer for you, and if so, how profitable. Hypothesis testing. Is there a difference? This is again, you can ask a question. Is there a difference in value to the company of these customers? Okay, you have various customers coming in to the store. You want to understand, okay, who's the more valuable customer for me? And again, you can figure that out through machine learning. Ads, I just gave an example of ads earlier on in the lecture. If I show this ad, what will happen? What's going to be the outcome? And what happened in the past? Let's say I showed certain ads. What happened? And in order to understand what happened, really to an accurate level, again, machine learning can be used. Same applies to products. You launched various products. Which product was what was the one that you want to expand on? What is it? Which one did the customer like? Now, all these things can be done through machine learning. Previously, they were being done, by hand, by building various models, but the amount of data that generally was being used was a lot less in the past than it is now. Now there's just a plethora of data that's being used. Again, the big data terminology comes from there. And so when there's so much more data that's being analyzed, the predictions are becoming a lot more accurate and more valuable to companies. Now, within machine learning, there are two categories: supervised machine learning and unsupervised machine learning. Now, in supervised, just imagine, so I'm going to give you an example of both of these, right? Now, let's just imagine, for the sake of this slide, and for you to understand these two concepts, supervised and unsupervised. Let's just imagine that an alien comes from outer space, and all of a sudden the alien comes and you put a whole big basket of fruit in front of the alien. And then you say, okay, I'm just going to give you some basic information. And you pick up an apple and you say, look, this is an apple. And then you put it down, pick up some grapes and you say, look, alien, these are grapes. Okay. And then you say, okay, these are bananas, right? And you show them. And these are cherries, right? So you show and you teach the alien that these are 4 categories. And then you say, all right, so that's your training data, right? So you trained the alien and you said, okay, these are 4 categories, and you show it to the alien and you make it very, very, very crystal clear. And you you use this as training data. So now the alien knows, okay, this is 4 categories of fruit. And then you take that fruit basket and you put it away. And then what you do is you bring out a big carton full of fruit. It's all mixed up. And you ask the alien to, based on the training that you gave them, identify which fruit is which and put them in separate categories. And so because the alien, had the data, had the training, was trained on training data, they can now, classify and say, okay, this is this, make separate categories. Now, this is an example of supervised learning. Okay, so you had training data that you gave the alien and you trained the alien. And then later on, you had test data, which was the actual big carton of fruit that you brought out. And you tested, and the alien was able to successfully identify and put the fruit in 4 separate categories that you had trained it on. And so this is supervised because you trained the alien. And so it's supervised learning, machine learning. Now, let's say if another alien comes, okay? And this other alien comes and you just do not say anything to the alien. You just bring out a big carton of fruit and you say, categorize these. And so the alien opens up the fruit and tries to see, and says, okay, well, there's some green fruit and then there's some red fruit. So it just decides to try and divide them based on red and green. And then you come back and you say, okay, that's fine, but can you, do more categorization? And so the alien says, okay, well, now I categorized in these two categories. Now maybe I can look at the red category and divide this in big and small size. And then he looks again at the green category, and again he says, okay, you know what, I can categorize these in big and small size. And so this is an example of clustering or unsupervised learning. And the reason it's called unsupervised learning is because you never trained the computer, you never trained the alien, never trained the alien. The alien tried to figure it out themselves. And so there was no training data. You just gave it the main data and said, okay, you just figure it out. And they tried to do it to the best of their ability. Okay, so at the bottom of the slide, there are various, they're given some details of within supervised learning, how exactly is it done? And I'll discuss that a little bit more. But in unsupervised, one method that they've mentioned over here is clustering. So again, clustering basically means bring together the similar categories, right? You break it out into big categories, exactly what we did over here, red and green, and then break the red category further in, and you only so that, you have within red, the small ones are separate, big ones are separate, and so on and so forth. That's, so hopefully now you've understood a little bit about what supervised data, supervised machine learning and unsupervised machine learning is. Okay, now here, this is an example of supervised learning, okay, and supervised machine learning. And so here, initially, you tell there's data. Again, I'm going to take the alien data, alien example that I just gave, and you brought in some raw data, meaning you brought in some fruit, right? And you labeled it and you told the alien that, look, this is an apple, these are cherries, this is a banana, this is these are grapes, and those are the various labels. And so you then trained the alien and you basically gave them a set of rules to follow, which is also known as an algorithm. And then you basically, you made the alien actually do it, right? Sorry, you tested whether or not you gave the alien a couple of things. You said, okay, are you sure? Show me. Can you? And he showed you, the alien showed you that they have learned the labels and they are able to make these categorizations. And you said, okay, good job, alien. You have now learned which fruit is which. And then when it comes down to it, you actually, so that's the left part, right? That's the whole training aspect of how you train the alien. On the right hand side, after you have trained the alien, you can give them, that big carton of fruit, unlabeled data. They will apply the model or the algorithm or the training that you gave them, and then they can easily predict which fruit is which, right? So effectively, this is how supervised machine learning is done. These, again, these couple of slides repeat a lot of the concepts that I've just said, but now that you've understood it, I'll read these out and hopefully you'll understand the concept fully. Supervised learning uses outcome variables known as labels for each record to identify patterns in the input variables or features related to the outcome variable. Correct answer label is known as training data. Label is applied by a person or already exists. Label data are used to train an algorithm using feedback, apply or test the trained model on new unseen data and predict the label. Again, this is exactly everything that I just explained in detail. Machine learning algorithms are primarily used to make predictions or learn about new unlabeled data. There are several classes of algorithms, and I will be explaining these categories in more detail to you. They are classification, clustering, regression, and associate learning. Okay, so I'm basically, for this lecture, I'll be focusing on the first three methods of supervised machine learning. So now, so just to give you an overview before I get into the details, up till now, you've hopefully understood the difference between supervised learning and unsupervised learning. And just to repeat it again, in supervised learning, you get trained based on training data. You establish a set of rules. You test it out to make sure whether the computer understands the categorization based on labels. And once the computer understands how to do the labeling, then your computer is ready to go. You can give it a lot of data, and the computer should be able to identify and make predictions based on the training that you gave it, right? So, but within this machine learning, within the supervised way of machine learning, there are certain categories. Excuse me. And so, okay, so the first type of supervised machine learning is known as classification. And this is basically what happens over here is you assign records to predefined discrete groups. And don't worry, I will explain all of this to you in detail. But I just want to go through this with you, this slide with you, before I go into the details and explain it to you. The second one is known as clustering. And clustering is basically splitting records into discrete groups based on similarity. Groups are not known a priori, not known beforehand. Regression, predicting values of a continuous or discrete variable. Associate learning, observing which values appear together frequently. And so I will be going in more detail and explaining you the first three. Associate learning is something that where computers are able to identify which values appear together frequently. So let's say, for example, an example of this associate learning is, let's say you've been researching buying a motorbike for yourself. And so you've been researching it, you've been going on Google and you've been, typing in motorbikes, and well, all of a sudden one day you're sitting and on your Instagram and on other social media platforms, ads for motorbikes start coming up on your news feed. And this is an example of associate learning which is supervised machine learning, where there was some sort of analysis made that you are interested in buying these motorbikes, and so these values started appearing together, and that's why these ads started coming up on your news feed. So that's just an example of associate learning. For the rest, let me give you a little bit more detail on the supervised methods of machine learning. There are three basic ones, as I mentioned. There are actually four, but there are three that I will be focusing on in this class. The first one is classification, and if you had to sort of visually look at how classification is done, it's basically done through these type of decision tree models. And so you have, let's say, weight, and it's if it's over, you know, yes or no, is it heavy or light? If it's heavy, then put in a separate category. If not, it's put in a separate category. Then, you know, another variable is looked at, horsepower less than 86. If yes, it goes into one category. If no, it goes into another category. Clustering, here you can actually see there are all these various points plotted on this graph over here, and they're put into two separate groups, two separate large groups. And I'll be going into more detail on how this is done, but the idea is that similar, you know, two categories have been made by looking at this data. And finally, regression. Again, in the beginning of this class, I went through it. And so, you know, machine learning also does regression to, but, you know, the difference is it takes a lot more data, looks into all of that while making the regression. So the regression obviously is more accurate. And so that's the difference. Okay. So let me go into a little bit more detail of classification. Again, you know, this is car mileage prediction, but there could be various classifications. Let's say if, for example, I had to try and classify your class, maybe I could say, okay, girls on one side, boys on the other side. Then within that category, within the girls category, I could say, okay, age above this, age below this. So you can make, this is an example of making a decision tree, right? So again, these are all methods where you use training data, you show the computer, you train the computer on how to do decision making. So you tell the computer, okay, look, you are eventually going to be predicting car mileage. But in order to do that, you train it using some training data and say, look, the first thing you should look at is the weight of the car. If it's heavy, then it's probably going to be high mileage. If it's not heavy, then you look at the horsepower. Is it less than or equal to 86? If so, it's probably high mileage. If not, it's probably low mileage. And so you make a decision tree, and you use this decision tree to train the computer, right? And these are a set of rules. So again, this is a kind of a algorithm. And once you test out that the algorithm that you know is working, and that it's, you know, it's been understood, then eventually you can feed in a lot of data, and through this algorithm, you know, it should be easy to predict, you know, the car mileage of cars, right? Just based on this decision tree model. So this is a model, right? You teach the computer the model, and then you give it a whole lot of data. Once it knows the model very well, you test it. Okay, does it know the model? Once you say, okay, yes, it knows the model, then a whole lot of data can be fed into the computer, and the model can be applied, and you will be able to get successful predictions. So that's the first method of machine learning. Now, here's another example of clustering. Okay, this is another method of machine learning. And so again, I'm going to take the example of an alien coming to planet Earth. And, you know, the alien comes in, and you say, okay, well, here you go. You put it in a jungle, and you say, okay, can you make certain categorization? And so obviously this is not, that would be unsupervised learning. But in this particular case, you identify that, look, animals are mobile, they're usually brown in color, they're running around, okay? So anything that you see that's like that is going to be an animal. Anything that's stationary in green is probably going to be and a plant. And so you give this basic high level understanding, you make that kind of a model where you explain that, and then you test it. We're using test data, and you say, okay, all right, here you go. Is this a plant or is this an animal? And the computer is able to successfully identify, okay, this is an animal. No, this is a plant. And so then you say, okay, great. Now this algorithm is understood by the computer. It understands how to classify things. And then again, it's easy for it to classify a large amount of data. Okay. And so that's the clustering method of machine learning. Now here's another method of machine learning, and this is the regression method. Here, you've basically gone in and you've understood, this is an example of, weight and age, and it's, based on the weight and age of a lot of, children, right? Little young children of, around up to 10 years of age. And so it's been plotted out over here. So, if what the age, according to age, what the weight should be. And so basically, now that this information has been plotted, if there's a new child of, let's say, age 4, then you can easily be able to kind of figure out, okay, how much should the child be weighing, right? And so these are various regressions that have been run, but let's say this middle one is the right one, and you look at it, okay, age 4, okay, well, this is how much they should be weighing, right? Now, if it's above or below, then you'll say, okay, overweight or underweight, right? So you're able to make predictions, right? Sorry, and this is, I believe, yeah, weight and height also. So 4 years of age, okay, you're gonna look right over here and you're gonna say, okay, this is how much they should weigh and this is how high what their height should be, right? So you get both of those predictions. So again, in regression, past data is being used, has been plotted out, a relationship has been found, it's been averaged out, and then based on that, you can predict what it should be. And if it's over or under, then you can identify that. All right, so that really covers, what I need you to know about supervised machine learning. Now I'm just going to talk a little bit about unsupervised machine learning. And again, this is the method where, you do not give a whole lot, you don't train the computer per se, or there's no model per se. What's done is basically clustering, and you give a whole big set of data and the computer looks to identify patterns or clusters of records. And once it identifies patterns, it says it is able to, and it labels those patterns. So it finds previously unknown patterns in the data without labels or guidance, and you don't give any guidance, right? So it's able to find those patterns on its own. And again, no training, testing, validation process is done. It's sort of able to do it on its own. If you look at it, how it's done, raw data is given to a computer. Algorithm is done on its own without any training. The computer is looking at a lot of information, analyzing patterns, and grouping various sets of data according to similarity. And that's how then predictions are made. Okay, once those clusters are made, then it's easy to identify, okay, this is a new set of information that's come in. Probably it's going to be in this category. All right, so that means it's category A. So that's how it's done. Now, after all of this, and I've described in great detail about, well, not in great detail, you can actually take a course, separate courses on all of this. There's a lot of information out there on all of these concepts that I just mentioned, but I gave you more of an overview, a high level overview of, what is going on in the business world as far as machine learning goes, and, various models. And couple of things I do want to mention about, these models is that you have to make sure that you use the right model based on the situation. If and based on the data that you have and what you're trying to predict. Another thing that is important to mention is that when you are training, using training data to train, let's say, the computer, and you're giving it an algorithm and all of that, you want to use unbiased data. You don't want biased data. So that, the computer will later on is able to understand the training data. Based on the training data, it's going to be able to make the predictions, right? So you want to make sure that the data that you train it with is not biased. It's unbiased data, it's accurate data. A couple of things I also do want to mention regarding using models. There are two things that people are very careful about when using models. Number one is they don't want much of a bias in the model. And what that basically means is they want to make sure that the underlying trend in data is captured. So this bias basically means, less bias means that it should be very accurate, right? And it captures all the data pretty much when it's making its predictions. Also, another thing that you don't want is that there shouldn't be a lot of variance in the model or sensitivity to changes in underlying data. So you want a very robust model. You don't want that, a small change in the training data will totally alter the entire model. You want it to be that it does not get impacted too much through variance. Again, you do not need to go into too much detail, but just high level for you to understand. And there's certain models that are underfit. And this is a situation where the model is too simple, and that's not a good situation because there's going to be a high bias. It's not going to be it's not really going to be capturing all the data trends, and there's going to be a low variance. But because there's such a high um, bias, it's not going to be a good model. And in overfitting, when the model is too complex, there may be less bias because it's capturing all the data, but there may be a very high variance, and that's also not a very good situation. So these are certain things that are kept in mind when looking at which model is a good model to use. So with that, I'm concluding this lecture. I hope you really enjoyed it. I personally find machine learning really fascinating, and I would highly encourage you to delve deeper in this if it interests you as well. Thank you very much.